So hello, welcome to the Internet of Water Peer-to-Peer Network webinar series. Today we have a presentation about the Water Data Collaborative's Mainstream Network and the Commons Water Reporter API. I'm David Yorkback. I'm a project coordinator at the Nicholas Institute's Water Policy Program, and I'll be your host for the webinar today. Before we get started, I'd just like to go over a couple of housekeeping items. So we are recording the webinar today, and the recording and presentation slides will be available on our website after the webinar. So if you'd like to refer back to anything you heard in today's webinar, or if you'd like to share this webinar with friends or colleagues, you'll be able to do that. We'll also be taking questions throughout the webinar. So if you have a question at any point, please drop it in the Q&A box down at the bottom, and I'll read it out loud so our presenters can answer it. If you have any technical issues, please put those in the chat, and we'll try to get those fixed as soon as possible. All right, so now on to the main event. We have Robbie O'Donnell, the Water Data Collaborative Coordinator at the Commons, and Gabe Watson, who is the Commons Data Journalism Lead. First, we'll hear from Robbie at the Commons. Sorry, a second here. There we go. First, we'll hear from Robbie. At the Commons, Robbie works to advance the Water Data Collaborative from concept to concrete offerings to build the national infrastructure to enhance community water quality science at the local scale in regional and national data-driven discourse and decision-making. Afterward, we'll hear from Gabe, who leads the Commons Knowledge Program at the Commons and develops narrative and analysis supporting environmental and social causes. Specializing in R, Gabe tackles a variety of projects with data analysis to help stakeholders enforce state water quality permits, advocate for environmental issues, and visualize water quality monitoring results. All right. And with that, I'm going to stop sharing my screen here, and I'm going to throw it over to you, Robbie, and I'll let you go ahead and begin.
Sweet. Thanks, David. I'll wait for this to get pulled up here. Thanks, everyone, for coming out. Me and Gabe are pretty excited to present some of the stuff here and talk about people and data pipelines. We'll go into and explain what we really mean by that. But to use two examples, we're going to use the Commons WDC Mainstem Network and the Water Reporter API. I am Robbie O'Donnell, and we have Gabe here as well. So let's dive into it, Gabe. So first, on the WDC side and the people's pipeline, if you want to think of it side, we're going to talk about, okay, why community science? We're really talking about community water science, but why do we need it? Kind of, why do we really care about it that much? Why is it so important here in 2022? Then we're going to dive into what the actual WDC is, what the Water Data Collaborative is, and then one of our tools that we kind of consider this people pipeline aspect, which is what we call the Mainstem Network. Gabe, you're on mute.
There we go. After we're done talking about people pipelines, we'll talk about data pipelines. And for this case, we'll be talking about the Water Reporter API. First, we'll talk about the Water Reporter platform, dig into the Water Reporter API. We'll look at some documentation, example requests, and then we'll wrap up with some use cases. And finally, we will have some questions on both the people pipeline side and the data pipeline side.
And with that, let's dive into what we mean by when we say people pipelines. So I know that sounds kind of like futuristic sci-fi, like something out of Minority Report or something like that. But what we're really talking about is people pipelines. How do we direct people and bring them together and give them the necessary resources to go forwards in their endeavors? And what we're kind of talking about here is mostly in water quality in our nation's rivers and streams and everything like that. So why would we need community science? I know everyone has maybe an answer already pre-logged in their head for this. But when the Water Data Collaborative was first coming around, back around 2017, we kind of noticed this gap in water quality monitoring. So Gabe, you can go to the next slide. This stat is as of, I think this was a couple years ago, but it probably holds still pretty true. Despite 50 years, I know this is the 50-year anniversary of the Clean Water Act here, there are still around 70% of US streams that are unassessed by federal, state, or local municipalities. So that leaves a massive data gap in water quality. So there could be a stream somewhere that's not being assessed that has some massive polluter on it, and we don't know. Thankfully, starting with the Clean Water Act, we have all of these hosts of NGOs, we have academic partners, we have service providers, we have all these organizations who are collecting water quality data, whether it's on their own, in their own watershed, whether it's a regional effort, whether it's a national effort, whether it's an international effort. So we at the Water Data Collaborative kind of all came together through this same mission of, okay, how do we bring these water quality groups together, get everyone on the same page? How do we get them collecting the same quality controlled data? How do we get that data? How do we increase the utility of that data? So it's not just applicable to me in my small watershed on my small lowly stream here, but it's useful to local municipalities, it's useful to the community, it's useful to the state, and it's useful to the federal government. How do we get it into decision makers' hands, basically? And what's unique about the Water Data Collaborative is that it's not just a single entity in a single sector of water quality. We encompass almost every single sector in water quality, except maybe like federal government or direct federal government. And we have service providers, we have NGOs, we have academic partners, we have large service providers, small service providers, we have organizations from all across the water quality sector who all kind of came together to answer this question and try and think of these resources to give to all of these many different stakeholders in the community water quality world of, okay, how do we all come together for this? Next slide, Gabe. And so one of the first things we kind of realized is that there's really this spectrum in community water quality programs. If you just think about community science, community water quality, think of all the organizations you know, whether you're doing it or you have volunteers or you have graduate students or anything like that who are collecting this water quality data. Think of the spectrum of those water quality programs. You have some who are maybe on this left side of the spectrum who have just started out. Maybe they don't have a QUAP. Maybe they don't exactly know what they need to sample for, but they know their stream or their river is dirty and they need to do something about it. Maybe you have organizations in the middle here who have a QUAP and they have like 1 or 2 sites, but they're not really structuring their data. It's still on an Excel sheet on someone's computer and they're not really sure what to do with it. And then maybe you have these programs here on the right that are well established. They have EPA approved or Chesapeake Bay program approved QUAPs. They're submitting their data to state water boards, to the federal government. They're submitting it via online platforms to their community so they can find out if they should swim or if there's a harmful algal bloom or something like that. So we have this large spectrum of programs. To kind of give an example of this, Gabe, you can go to the next slide. This is an example of a real life organization and a real life field sheet that was sent to us at the Commons. And this is a very good example of maybe a program that's on that left end of the spectrum. Maybe they're just starting out. Looks like they have some pretty rudimentary field sheets where they're collecting some physical and some observational data. Looks like on this day when it was collected, it was 69 degrees and partly cloudy. It looks like the wind was blowing at 9 miles per hour that way. But I guess if I turned this way, it may have been going this way. And so this is a really good example of the level of data that's being collected. It's not necessarily bad data. It's still good. It's visual observational data. But when compared to, next slide, Gabe, organizations maybe like this is the James River Watch, which was built, this app was built by Gabe here, via Water Reporter connectivity into the Water Reporter data management system. This is an example of a really good, well put together water quality program. They have their own web application pulling from machine readable online data with visualizations. They share this with their community. This is the James River Association. They have quality controlled programs. They have upwards of, looks like almost 30 sites here all across the James River watershed, which is the longest river in Virginia, actually. And so they have a pretty well-established program. So you see these juxtapositions of these two programs, and then you have everyone in between. So the WDC really looks at, okay, how can we build everyone up? How can we get everyone to this stage? And if everyone's at this stage, then we'll have some pretty comprehensive water quality data that's going to be pretty useful to state decision makers, to researchers, to the EPA, to USGS, to USDA, whomever. It's going to be very applicable to them and fill in all these data gaps that we've seen over the past 50 plus years. All right, next slide, Gabe. And so at WDC, we kind of focus on these four, call them pillars, call them what you please. These are some that we kind of thought of. One is champions. You can all think of those champions who are maybe on that right end of the spectrum. These water quality programs, these water quality organizations, these networks, whomever, who are doing things exactly right. These are the good examples to other water quality programs who can teach them something. These champions have good stories to tell. They have good pros and cons of all these things. They have good protocols. They have things that can tell you that worked well, things that worked poorly. And so we like to focus and highlight these champions to help out other groups, maybe who are in their own watershed, maybe who are in adjacent watersheds, or just across the nation in general, to learn from them. Then we go through into this networks of networks. This is kind of leads into or from champions. Networks of networks, you can kind of think of this as exactly as it sounds like. Everyone can think of larger monitoring networks. As an example, water keepers. There are hundreds of water keepers across the world and the US. And so that's one monitoring network that we can tap into. If we have water keepers like the James River Association has a water keeper program, if we can tap into that network, then they can help teach other water keepers how to maybe manage their data appropriately, maybe organize their data, develop a really good QOP or a study design or something like this. So if we can tap into these networks, then we can really start to reach more organizations to get everyone on the same page. Grant funding is pretty self-explanatory. In my personal opinion, I used to work at Anacostia Riverkeeper in Washington, D.C. These programs need funding. One of the biggest things people ask me is like, well, what kind of resources can we give maybe small NGOs, or can we give these monitoring networks and stuff like that? They're already doing a lot of this work. They just need funding and support to do it. Like they can monitor 2 sites with X amount of dollars, but they could monitor maybe 50 sites with way more dollars. So grant funding is a pretty high priority for a lot of organizations, not just NGOs, service providers, larger NGOs, academics, everything like that. And then finally, distributed data management. So this is the lead into the data pipelines aspect of it. So if we can bring people together through all these pillars, then what do we do with the data? If everyone's collecting this amazing data, how do we feed this data into useful applications, useful tools, get it into decision makers' hands, and all of these things? And so for WDC, next slide, Gabe. For WDC, we focus on the people pipeline and the data pipeline, but what I'm going to talk about is the people pipeline. So for WDC, we have this tool that we developed called the Mainstem Network. So the Mainstem Network, in its base usability, think of it as almost like a social network for community water quality programs. Whether you are a academic institution, whether you are an NGO, whether you are a state water board, whether you are just a private company who collects water quality, anything like that, the Mainstem Network is a place for you to come, learn information, find resources, specifically connect with people. Because one of the biggest things we've noticed is just this siloing in the community water quality world, that people just aren't talking to each other. They're monitoring the same things and they don't even know it. One group is monitoring over here and the other group is monitoring right next to them and they're not talking together. And so we want people to learn from each other. And if we can develop these people pipelines where people are finally talking, they're building larger monitoring networks, they're sharing resources, all of these things, we can start to develop these people pipelines that lead to much more quality controlled data, much more well-structured data, data that is more usable, we will say, and able to more appropriately fill in those data gaps. And so what the WDC Mainstem Network can do, it is live and free to join right now. If you can just go to www.mainstemnetwork.org, you can go to the next slide, Gabe. We have a bunch of different modules, but a lot of the offerings we have are opportunity listings. So you can go next and next. We have opportunity listings where you can list volunteer opportunities for your monitoring program. You can list funding opportunities if you're a funder or a foundation. You can list jobs if you're an organization and need to hire a monitoring coordinator or something like that. You can list it in these opportunities tabs. We have communication, whether it's through direct messaging or we have a live feed as like the homepage, as you would in any social network. this is not really meant to be a location where people come and hang out, so to speak. You're meant to come here if you have a specific question, you want to connect with someone. You're like, what are they doing in terms of water quality around Cleveland? I can go and search for organizations and people who are monitoring around Cleveland on there and ask some questions, see what they're doing, share my knowledge, find their knowledge. Next slide, Gabe. We have networks that you can actually build yourself. A really good example of a monitoring network that is in existence right now is the Chesapeake Monitoring Cooperative. This is run through Alliance for the Chesapeake Bay and the Bay Program and a bunch of other organizations. And it's basically just a Chesapeake Bay-wide monitoring network where organizations combine together to upload their data to a data visualization platform, to a database, and that data is able to go to the Water Quality Exchange, it's able to go to the Bay Program. It's being able to be used in a much more higher capacity than if I was just over here in my Anacostia watershed collecting my data and keeping it on an Excel sheet somewhere. And so if I wanted to manage that network on the Mainstem network, share QOPs, share training manuals, share ideas with volunteers or scientists or researchers or whomever, I can join and create my own network and have everything built in right there. Next slide, Gabe. There's also a monitoring program index. This is actually what's something we're really excited about because we're trying to have a full accounting of these monitoring programs that are occurring across the US. I know a lot of people have been doing this or have been trying to do this, but we want it in one place all at once and searchable by region and filter and everything like that. So you can filter by region, you can filter by all these different things and try and find monitoring programs that are maybe in your area, say in the Chesapeake Bay watershed, or maybe just in the Potomac watershed where I am. And maybe I can start talking to these organizations that way. Use it as a first step to really start kicking off these conversations. Next slide, Gabe. And you can go next and next. What's also really nice is you can share resources, you can share PDFs, docs, QOPs, PPTs, whatever docs you want to share, you can share them back and forth and just use this as a data repository for any of your monitoring programs or anything like that. We also have training and study design modules that we're building out as well, that we're kind of rolling out hopefully in the next year or two. Next slide, Gabe. What's interesting about this is that it's relatively new. So in May of 2022, we kind of had a beta launch for this. In June of 2022 is when we actually released it in a soft kind of launch to the public. And now from June of 2022 to the end of 2022 is when we're seeing what works, what doesn't work, how folks are using it, and all these types of things. So you can join right now for free. Like I said, we're coming out with a mobile app version as well that you can actually get on your phone for Android and iOS. That should be out within the next couple of months as well. But right now, just in 2022, we are trying to get at least 100 users into the platform and 50 organizations by the end of 2022. I think we are almost to that number actually, which is pretty great. But if we can get to this point, we can start to see how people are using it and kind of tailor it to organizations and people to help them better facilitate these conversations, hopefully break down some of these barriers that people may have and get people just to talk to each other more. Really is the base necessity for this kind of people pipeline, this tool that we have. All right, next slide, Gabe. And then finally for WDC and the Mainstem Network in general, if you want to expand the actual Mainstem Network offerings, really focus on regional collaborations among water quality groups. So how can we build these larger regional water quality networks that are all working in tandem, all working together and collecting all this data and sharing it with each other? We want to continue to work on this open source platforms and water quality data, which Gabe will kind of get into a little bit more with the data pipelines. And then we just want to work with agencies and watershed groups to explore standardization protocols. So if we can all agree on standards for water quality collection for different parameters and things like that, then we can maybe get all on the same page and start sharing data in a much more accessible and easy way. And with that, I'll hand it over to Gabe.
Sweet, thanks, Robbie. So now let's talk about data pipelines. Data pipelines, to be able to get to this point in the process, things like the WDC Mainstem Network collaboration and groups really speaking the same language to be able to have consistent data models, store their data in the same place, basic elements like having parameters be named the same or using the same units if you're collecting dissolved oxygen, whether it's milligrams per liter or percent saturation. Data pipelines able groups to basically get that data and then port it over to visualizations to be able to perform analysis, annual reports, and other types of end user data products. So let's jump in. So to talk briefly about the Water Reporter platform that the API is run off of, the Water Reporter platform allows users to collect, share, and visualize data. So a group can basically submit water quality data, have that stored in the cloud, and then be able to turn around and visualize it. So it has both mobile and desktop interfaces. It also allows for multiple basically group owners and volunteers to be able to submit data. So you can have folks taking water quality samples at one stream, and then some other individuals taking pictures or doing water quality in another location, and basically all submit to one central place. There doesn't have to be sort of a bottleneck for one person to deal with the data to be able to get it into Water Reporter. Water Reporter also supports both observational and routine monitoring. So observational monitoring program is like if you have volunteers across your watershed and you basically train them to take photos of, for example, certain types of pollution. Maybe there is a certain industry in the area that's known for having pollution come out of their outfall, and you want folks to take a picture, write up a quick note about it, and post it to Water Reporter. It also supports more robust routine monitoring. So the groups that are collecting water chemistry data, doing temperature, dissolved oxygen, pH, bacteria, submitting samples to the lab, and then having that get returned. It supports all of those different types of water quality data, everything from the observational to the routine. And then at the end of the day, you're able to then visualize your data in our out-of-the-box mapping feature. Here we're looking at Blue Water Baltimore's map. And if you notice, some of the stations say fail, some of them say pass. So we're looking at the bacteria parameter, and in Water Reporter, you're able to put in thresholds basically to mark at certain points when there's cutoffs for acceptable levels of whatever your parameter is. And then you're able to turn around and have that data then colored properly. The charts basically have like horizontal lines to indicate the thresholds. So it's really kind of a one-stop shop for watershed organizations to be able to collect, share, and visualize their data. So now we're going to talk a bit about the Water Reporter API, but briefly, I just want to talk about APIs in general. So you might have heard that term, but what is an API? An API is a framework for transferring data between websites, databases, applications, and really anything else that might live on the internet. So if you're in 2022 and you're using the internet, you're probably interacting, or not probably, you are interacting with APIs often without even knowing it. A really common example is if you're buying something on Amazon or another e-commerce website and you put in your credit card, that credit card number gets sent to encrypted, gets sent to your provider to basically double check, hey, is this the right date, zip code, and security code. And then the credit card company basically sends back a, yep, that all checks out, and your e-commerce site is able to move forward with the purchase. So that's one example, but APIs are really ubiquitous across the internet, and they're really starting to be proliferated into the environmental data space and the water quality data space as well. So as mentioned by David at the beginning, I use R, the statistical programming language, as sort of my main tool for analyzing and visualizing data. So I just want to kind of cover a few like really common APIs that I use in my work, as well as some sort of sister R packages that make accessing these APIs really easy. One example is USGS. So USGS has like 10,000 plus stream sites basically around the country that are monitoring temperature, gauge height, discharge rate, and all that type of data. You're able to get that data, query against stations, look for stations with particular parameters, and a variety of other aspects through their endpoint at waterservices.usgs.gov. If you head to that link, you can take a look at all of their documentation. It's quite a robust API. And then there's the sister package that makes interacting with that API in R super easy, and it's called data retrieval. So hats off to the USGS for generating packages for their API to make interacting with them a lot easier. You may have also heard of EJ Screen, a tool for identifying a certain geography's vulnerability to pollution and also their resiliency to pollution. So you can access EJ Screen API data, or you can access EJ Screen data through their API, I should say, at ejscreen.epa.gov/mapper/EJ Screen API. And what's really cool about this one is you're able to actually build API queries in their mapping application. And as well as USGS, they also have a sister package called EJ Screen, which allows you to access the data in R without building out full API queries. And then another component I just want to highlight that is often overlooked when we're talking about environmental data is state data portals. I use these all the time in my work, and they're often an underutilized resource. And a lot of states are moving their data to a state data portal, which allows folks to not only download and look at the data, but also access it programmatically. So states like Maryland, Virginia, and Pennsylvania all manage their data through a platform powered by Socrata. And Socrata also has an R package, which allows you to basically pull in data sets with like one line of code. So if you're looking for boundaries on watersheds, if you're looking for permit data, if you're looking for locations of parks and other entities, if the state has it in their data portal, often you can get it out via an API. So Socrata doesn't build every state's data portal, but I would check out your local state and see if you're able to get the data programmatically. And there's a use case I'll show you at the end that's run off of a state data portal. So let's dive into the Water Reporter API. So briefly, it's an API for watershed organizations, and is really built around four main pillars, you could say. First and foremost, it's to build custom applications. So being able to take data out of Water Reporter and then visualize it to a particular client spec. We see this a lot at the Commons. Another component is expanding analysis. So if you want to run a monthly or yearly report on your data, and you're looking for particular charts, particular visualizations that you as a data scientist have in mind, you're able to take the data out of Water Reporter, feed it through a script that you've made, and basically visualize that data with one click. So if you're running the report, you don't have to take the data, download it, put it into Excel, generate the charts, put them into a PowerPoint. You're able to basically make a script, pull the data, and hopefully run it basically with one click at the frequency that you need. Another component is we wanted the Water Reporter API to be accessible. So we put a lot of effort into the documentation to make sure that folks without basically a high developer background are able to utilize it. So if you have any experience in doing web development in HTML or CSS, and if you are a data science practitioner using Python, R, or JavaScript, it shouldn't be difficult for you to get your head around the Water Reporter API. And last but not least, we wanted to foster collaboration. And this kind of ties into what Robbie was talking about with the people pipelines. But not only are you able to basically look at a particular group's data, but if you have a regional effort, you're able to get data for every group in your effort and compare the data across watersheds, across stations, across parameters, and be able to get a real like 10,000-foot view of a particular geography. So we found that the Water Reporter API is able to facilitate a lot of these regional efforts by bringing the data all kind of into one place so that it can be analyzed, visualized, and whatnot. So those are really the four main pillars. And just briefly, to be able to access the Water Reporter API, you need to get a public access token. If you're not a Water Reporter member, drop us a line at support@chestcommons.org to be able to get an access token if you're interested in just kind of playing around with the data. If you're a group and you want your data to be publicly accessible, in your data source under the visualizations tab, you want to make sure that you've checked the box to turn your data to public. By default, all data in Water Reporter is private because we think it's important that groups really have full control over their data. And if the data hasn't been certified, if it hasn't gone through their own QA/QC process, quality assurance and quality control, the data just isn't out there for anyone to access. But if you are a group that you want to run some analytics, be able to use the API, you have to uncheck that box and set the data to public. And so let's now move to the documentation. Like I mentioned before, again, we wanted this documentation to be really accessible and for folks without a really strong developer background to still be able to use it. Likewise, we wanted to make sure that anything that was really stored in Water Reporter for groups that have been using it for a really long time and have all of the thresholds filled out, have a multitude of stations, data sets, and really complex data structures, we wanted to make sure that you could get all that information out. So when you access the documentation, you can get that at github.com/waterreporter/API reference. You're able to see example requests. You can look at the different parameters under the requests, and you can also look at expected responses. All the responses are returned in JSON format, which if you've interacted with APIs before, that's kind of the standard format that data is returned by. So now let's dive into a few of, or all of, the request options that you can get with the Water Reporter API. You can get data sets, stations, readings, parameters, and then these two extra requests, watersheds and posts. Really, the data sets, stations, readings, and parameters are kind of the bulk of the API where a lot of the functionality lies. And those requests model directly to the data model in Water Reporter. So you'll see in a little bit, I'll show a use case, and I'll be talking about data set IDs, station IDs, parameter IDs. That's kind of the main nugget of information, those IDs that you'll need to be able to interact with the API to be able to get the data that you need. If you're just exploring data and you've accessed all of the publicly available data sets in Water Reporter, you don't necessarily need to fetch those IDs like from Water Reporter itself. You can kind of build out applications and reporting workflows by just interacting with the API and programmatically fetch those IDs, whether it's data sets, stations, or readings. And then on the left here, I just got an example of what a response looks like. For a reading response, you can see at the bottom before the parentheses value, that's like the actual reading value being returned. In addition to a lot of metadata, you can see like the color as it relates to the threshold, the data set ID, and a bunch of other metadata information. And then at the bottom, I've got an example of a readings request function written in R. As you can see, it's pretty short. And basically, this readings request takes a station ID, a parameter ID, a limit, which sets the number of responses you'll get. I believe it's capped at like 100, but you can set that to be 10,000 to get basically all the readings stored under a data set. And then as well, it takes the token that I talked about earlier. The last two requests I'll talk about, watersheds and posts. Watersheds, as the name describes, it allows you to get a watershed for a particular location. We found that this was something that when people are building applications is really helpful. Also, when you're doing data analysis and you want to basically analyze by watershed, you can get locations like hydrological unit code for 2 all the way up to 12 if you're familiar with HUC code standards. And then lastly, posts. I mentioned at the very beginning on Water Reporter for that observational monitoring, when folks are just like taking pictures of instances of pollution, or it's a nice day out, for example, that observational monitoring, you can also get that post data. So it's different than the quantitative data that you'll get out of the dataset stations, readings, and parameters request, but it's definitely an important component of a lot of watershed organizations. So we want to make sure that we're revealing that post data through the API. So now let's jump in and look at some use cases. We'll talk about some applications that we've built off of the Water Reporter data, and then a workflow that utilizes the watershed request function. So really the first application that we built off of the Water Reporter API, and this application was kind of, let's build something ourselves so that we can vet the API, make sure that it serves the purpose that it's intended to. And so we developed the station card. The station card is really a mobile-oriented application to complement our desktop view map that I showed you with Blue Water Baltimore earlier. And the station card runs off of the Water Reporter API. And just briefly, a few of its sort of main features. Really, it's geared towards addressing the central question, what is the current water quality near me? Where are the other monitoring stations in a data set? So when you first open it up, you're able to see basically all of the stations in a particular data set. You can click on them like we've clicked on Stony Run here in Baltimore. And at one point I lived maybe a few blocks from here. I would head down to the Stony Run Park. And I've got a very cute dog. She loves to run in the stream. And I'm always curious, is it safe for her to swim? A really simple question that we often ask of our data. And we found when we were developing the station card that often people are asking that question when they're like, stepping into the stream or right before, like, wait, is it safe for me to swim? So being able to access this data really in a really accessible way in your palm, like right when you're there, is a real key component of the station card. In addition, you can generate a QR code for a particular station in a particular parameter. We've seen a lot of groups start to develop basically QR codes that are printed out and then put near where they're collecting data. So folks can scan it with their phone and then it brings up the station card. And just, it's important to note that the station card is not like a application that you need to get on the App Store. It's web-based. Basically, it runs on your browser, which facilitates really easily basically accessing that data without having to download an application. It's really lightweight and runs in environments without a really strong internet connection. Beyond that, you can configure stations and parameters. If you take a look at the top at the URL, you can see in orange that dataset, station, and parameter codes, and green are the IDs. So for Blue Water Baltimore's case, their data set is 860, the Stony Run station is 8772, and the parameter for bacteria is 666. So when you're interacting with the station card, that URL basically automatically updates as you're navigating through different stations and parameters. And so you're able to say, hey, let me send this particular view to my friend and have it already open up to the data set, station, and parameter. We think that's a really helpful feature, especially in the situation where you're like scanning a QR code and you want to bring up the data for that location. We wanted the application basically to kind of know what view should be shown. And then I'm going to move on here to another use case that we developed. This is an application we built for California water boards. And this again kind of ties into what Robbie was saying about getting those like regional efforts together. So this is a project which is focused on monitoring data associated with harmful algae blooms in California. And this is a multi-group application. All the data is stored in Water Reporter and basically accessed through the Water Reporter API. We developed this in the Angular format, so it's a totally custom interface built for California water boards. And what's really nice about this is to add another group, because this, in a perfect world, this regional effort is expanding. There's more groups coming on, there's more data coming on. So to make updates to the application, all you need to do is add the dataset ID, and then the application automatically basically adds that to the list. So here we're looking at Karuk Tribes data. We also have Keep Tahoe Blue, Big Valley Band of the Pomo Indians, and other groups, and hopefully more groups will come on as the effort grows. And last but not least, I want to talk about a recent project we just finished with Chesapeake Legal Alliance. We had originally built an application called the Violation Tracker, which displays permit and inspection results for facilities and construction sites with wastewater discharge permits in the state of Maryland. There's roughly 10,000 of these facilities, and there's over 30,000 inspection records. And when the application was first built, Maryland Department of the Environment stored their data on their own site. The data wasn't programmatically accessible. And thanks to the efforts of Chesapeake Legal Alliance, MDE, Maryland Department of the Environment, was forced to basically move that data to the Open Maryland Data Portal. This allowed us to basically update the application automatically through an autonomous worker, which in short is basically a script that runs on the internet and pulls in data from Maryland Open Data Portal, in addition to geocoding the facilities and construction sites that are added every, I think it's roughly like 3 or 4 are added every day. And lastly, how this ties into the Water Reporter API is I leaned on the Water Reporter watershed request function. Because as we're displaying the data on the front end application, it's helpful to know what watershed a particular facility or construction site falls into. And to get that data, we use the Water Reporter watershed request function to basically send just a lat long pair, and then the API returns what watershed it's in. So the Water Reporter API is hanging out with a bunch of other APIs basically in this worker, and it seamlessly takes data from a state portal, combines it with all those ancillary data sources, and then pushes that data to the front end application, and it's updated daily. So those are just a few use cases of ones that we've developed, and how we see basically the Water Reporter API being able to facilitate getting water quality data and these other data components like watersheds sort of out of your typical kind of spreadsheet, or in worst case, as Robbie showed, paper format, and actually get that data onto visualizations without having to have someone download the data and manipulate it in a classical way, like in Excel or Google Sheets. So we really think this has kind of opened up the door a bit for folks who are on the Water Reporter platform to be able to do more with their data. And we're excited to see other applications be used from it. Again, all of the documentation is on GitHub. Just search GitHub Water Reporter API documentation, and you'll find it. moving on to questions. Do we have any questions in the chat just before we kind of jump into these?
And yes, hi Gabe, this is David. Let's see, we do have a few questions here. We have, let's see, does the Water Reporter platform or API do anything to help harmonize data or make it easier to integrate, compare data from different sources? We're curious about the metadata practices.
Yeah, so that's a great question. And it is still kind of dependent on how that group is collecting the data. So I've actually just started a project in the Great Lakes region. There's the Lake Erie Basin Assessment Framework where all the groups are monitoring data with the same parameters, the same units and whatnot. And that makes it really easy to be able to pull in the data and be able to do cross-group analysis without having to worry about sort of the typical issues associated with water quality data. Again, is it dissolved oxygen saturation or dissolved oxygen milligrams per liter? Is it, and so in short, no, the Water Reporter API doesn't do any real harmonizing. One component that you can get from the metadata is a normalized name. Basically, the Water Reporter system is able to infer what the users typed in as a parameter name, so that if you're getting a bunch of different groups and things are spelled differently, you're able to kind of assume a bit about what the real parameter is. But I would say that for folks who are doing any sort of analysis, it's best to kind of know the protocols for the data that you're dealing with, the frequency and how it's collected, how deep in the water column it's collected, all those different variables if you want to say anything authoritative with the data.
Okay, great. Thanks for that, Gabe. We do have a couple of other questions here. One is also, does the Water Reporter app, does Water Reporter integrate with DataStream?
No, it does not.
Okay, thanks. And then another question, this is specific, I don't know if you'll be able to answer, but for people who live in Africa, what are they supposed to do?
In terms of managing your water quality data, I mean, I guess there isn't any barrier based on continent. We've got some users across the globe. I know we have a strong contingent of folks monitoring in Mexico, specifically the Tijuana area. So there really isn't there really isn't a barrier. I will say that the Water Reporter platform is all in English, and we have thought about translating it. The first would be to Spanish. But I wouldn't see any particular barrier. It would be agnostic to the content, the continent that you're on.
And in terms of like people pipelines, like WDC has kind of started out as a US and kind of Canada-based focus, but the stuff we're trying to do is pretty, like Gabe said, agnostic across countries. And so those same questions and those same issues that we're dealing with, I'm sure you have the same thing in parts of Africa. Probably people have the same things in parts of Europe and Asia and Australia and South America and Central America and all these areas. And so those same principles of trying to break down barriers, and it is very specific to how water quality and water quality monitoring is set up in your country or municipality or wherever. But a lot of those same principles and ideas are universal in how they kind of can be applied to wherever you are. And I think, Gabe, as an aside, I think some Water Reporter data does go to DataStream because Buffalo, Niagara, Waterkeeper does provide their data to Water Reporter, which I think is also going into parts of DataStream or something like that. I could be wrong, but I think some of it does go to DataStream.
Yeah, I can maybe I jumped the gun in terms of integrating Water Reporter data with any other platform. It's a simple issue of a developer basically creating that integration, writing the script to be able to get the data out of Water Reporter and then combine it with any other data flow. So is there an integration in the classical sense? Like, can you click and say, send it to another platform? No. But the beauty of APIs is that if you have some developer experience, you're able to take the data and put it wherever you'd like.
Okay, great. Thank you. And a couple more questions have come in. Let's see. Is it possible to add more indicators or parameters to measure, like biodiversity indexes?
Yeah, so that's a really good question. The Water Reporter platform both supports quantitative data as well as qualitative data. So if it depends on kind of how you're structuring your data model. But if you were to, for example, have like an IBI score, a macroinvertebrate score, you could put that data into Water Reporter under a quantitative field and be able to get that out through the API.
Okay, great. And could water quality groups be a link to the citizen science concept?
May have to provide more detail on the question. I'd say yes, because I mean, not all water quality groups are conducting citizen science per se, but they can.
Okay, great. Thanks, Robbie. Let's see. Somebody else just saying thanks for this webinar. One of the question is, can the water depth data taken for large, let's see. Can the water depth data be taken for large river like the Ganges?
So if this is a question for the Water Reporter API, totally. You can add, maybe it's helpful if I take a step back. What's really nice about the Water Reporter platform is that whether you want to monitor those sort of classic parameters like pH and water temperature, or you want to get, you're monitoring for heavy metals, for example, or, a location specific pollutant, you can add a field and collect data under that field. So if you want to add some ancillary metadata like water depth, which is really important for, folks who are monitoring on deep rivers or in lakes, the temperature at the surface versus 50 feet down is obviously going to be different. And that's important when you're collecting the data. You can totally add that information. So when you're submitting a sample, you have what water depth the sample was collected at. And then in turn, if it's in Water Reporter, you're able to get it out through the API.
Great, thank you. And we have an important question that came in, I think, at the very beginning, which I think was referencing the first or second slide you had up, which is, where is that kayaking run? And which one of you is it in the kayak in the photo?
I wish.
I will say the kayak references are an ode to our executive director, John Dawes, who is an avid kayaker. I've only been canoeing a few times, so I can't say.
So we'll say it's John in the photo then.
It's John in the photo, yes.
Start that rumor.
Great. Well, that is all the questions that have come in so far. We still have a few minutes, so we can give a few more minutes to see if anybody else has any other questions. And I know, and we have a few questions that are on this last slide of if either of you would like to address any of those.
The ones I posed were just kind of, they're more rhetorical questions than they are actually direct answerable questions. But I mean, those for under Mainstem Network, those were the two original kind of thought processes that we went through. It's like, okay, how are we currently collaborating with other water quality groups? And then if I was a water quality group and I was like, okay, I need to conduct a program, but I don't know where to start, where's the first place you would start? And why did you choose that? And what was the thought process behind that? And then hopefully we can start to see, okay, where are people going? How can we collaborate in these types of things?
Great. Let's see. Well, I just want to say thank you both, Robbie and Gabe, for this great presentation. Really appreciate it. And yeah, it doesn't look like we have any more questions coming in. So I think we can give people a few minutes back at the end of this hour. And I guess I will say we have another, the Nicholas Institute has a water policy program webinar coming up on November the 17th at 2:30 p.m. And that will be, we're going to have a person from FERC, from the Federal Energy Regulatory Commission, talking about the relicensing process. So we'll have that up on our website soon, and please just check back on our website for further upcoming webinars. And Robbie and Gabe, once again, thank you so much. We really appreciate your time today.
Thank y'all.
Thank you, David. Thank you, everyone.